All right, guys, in this next chapter, we're going to be looking at momentum. And momentum is very similar to inertia that we looked at before, except now we're going to be putting numbers and equations to that concept. So if we look at this statement, the team has momentum, let's win this game. What do you think of when someone says that? So, you know, often when a team has momentum, that means they're going in the right direction, they're making progress, they're, doing a great job. So, that's something to kind of think about when you think about momentum. If we look at our little angry bird here, if we try to determine the momentum of the bird, we can determine the momentum of the rock, but momentum is going to be mass times velocity. So it is a vector quantity, and the unit is going to be a little bit different. Here it says kilograms times meters per seconds to the -1. We can write that like this. So kilograms times meters per second, which is just mass times our velocity units. So if we were to try to figure out the momentum of the bird, we would do his mass of 1 times his velocity of 3, and we would just have a momentum of 3. What about the ball? So it's not moving, so the velocity is going to be 0, so his momentum will be 0. So momentum, you can think about it in terms of inertia that's in motion. The equation for momentum, like we said, was mass times velocity. Now the symbol for momentum is p, a lowercase p. Now, this might be confusing when we start using lowercase p for momentum. We just talked about power in the last chapter. So, watch out for that. We can't use m for momentum because that's mass. So, the symbols start getting a little crazy. So, we're going to do a couple of these. Very simple. Determine the momentum of a 60 kilogram halfback moving eastward at 9 meters per second. So all we're going to do is 60 times 9. We do need to take direction into account. So eastward would be positive, westward would be negative. So 540 kilogram meters per second. How about a 1,000 kilogram car moving northward at 20 meters per second? So north is positive, south is negative. So 20,000 kilogram meters per second. And the last one, a 40 kilogram freshman moving southward at 2 meters per second. So southward means it's going to be negative. So 40 times 2, negative 80 kilograms meters per second. Impulse is change in momentum. Now we can find impulse by our force multiplied by time. So we can say that force multiplied by time equals change in momentum. Now, if we're going to increase our momentum, that could have an impact on our force or our time. So, if we have a large momentum, we want to, that'll either give us a large force or a large time. So, we might want to be, changing the force of impact on something so things don't get hurt. So, I often have you guys, somebody do this in class, but try this while you're watching this video so you can kind of see what I mean. So, what you'll have to do is jump, stand up, jump. And the first time you need to jump, jump with your knees straight, don't bend them. And then the second time, jump, but bend your knees like you normally would when you would jump. And you're going to notice a big difference. So, when your knees are straight, it's not going to feel really great. So, what's happening here when your knees bend? That's increasing the time of impact, which decreases the force on your body. When you have your knees straight, the time is decreased, so then the force is increased and doesn't feel real great. So, if you have a crash and you have something you're going to have an impact, you want to extend the time for that impact. So we have things in our cars like airbags that increase the time where we are impacted to decrease the force, or bumpers on our car, things like that. So this kind of goes back to that same thing. So why would we have a padded dashboard? So if you have a very hard dashboard, again, that time is going to be decreased, or if it's padded, it's going to give you cushion and allow for a longer impact. Now, your homework today is going to involve this egg drop demo, and you've got a formative to go along with it. So when you pull that up, it's going to give you some scenarios. You just make sure you follow along with the instructions, read it very carefully, because you're going to look at dropping an egg, will it break, in different scenarios and things like that. So if you have any questions, let me know.